now let's talk about arithmetic operators. So we already know that arithmetic operators are used to perform numeric calculations. C++ has unary, binary, and ternary operators, and what that means is a unary operator means that you have one operand. So what that means is you have, say, -5. So if we're just looking at this, we know, okay, that's the negative in front of the 5, and we know that's -5. But what this negative is in C++ when you're writing your code is this is the negation operator. So that's a unary operator. Binary operators are operators that have two operands. And so this would be things like 13 minus 7. So when we have 13 minus 7, we have two operands. So that's the 13 and the 7. So basically any math where you have like 13 minus 7 or 13 plus 7 or 13 times 7, that's considered a binary operator. And then there's also ternary operators, and we're going to talk about these in a later chapter when we talk about if and else statements. But the ternary operator has three operators. So it has, say, an expression, and you check to see if that expression is true or false. If it's true, you're going to execute expression 2. If it's false, you're going to execute expression 3. And we're going to get into the details of this a little bit later, but basically with this you have three operators, so that's why it's called a ternary operator. What I want to talk about now are specifically the binary operators. C++ has the usual operators that you would expect, like addition, subtraction, multiplication is a star, and I'm sure you've seen that used symbolically in math with your calculator. Division, and what's called the modulus operator. The ones that I want to spend, I think the plus, minus, and multiply are pretty straightforward. The ones I want to spend some time talking about are, first of all, this division operator, just because you can end up with different stuff depending on if you're doing integer division or not. And so this division operator performs integer division when both operators are integers. Both operators, and what's meant by that is that basically, like, it'll divide your numbers and it'll just truncate the remainder. So if let's say we have 13 divided by 5, this is going to give you 2 with integer division. 91 divided by 7, so 91 divided by 7 is going to give you 13 using integer division. If one of these numbers is if you have two floating point numbers, it's going to divide with floating points. But if you have a floating point and an integer, it's going to convert the integer to a floating point, and then it's going to do the division. So let's say that you have, well, if either number is a floating point, it converts answer to a floating point. So an example of that is, let's say that we have 13 divided by 5.0. So since we have the 5.0, that means that's a floating point number. So 13 divided by 5.0 is going to result in 2.6, whereas when we had the integers, 13 divided by 5 was 2. So the integer division truncated the 6, and then with the floating point, you got the 2.6. And then if you do, let's say we do 91.0 divided by 7, so since we have a 0.0 on that, it's a floating point number, and this is going to result in 13.0. So this is something that can be pretty important if you're doing mathematical operations. And so you might think if you divide 13 by 5, you might think that you're getting a floating point when you're not, and it's important to remember this 5.0 to kind of force that number to be a floating point. So we're gonna practice a little bit with this when we look at some example code, and look at integer division and floating point division using some code. But okay, so now let's look at the modulus operator. So basically what the modulus operator does is it computes the remainder from the integer division. So the modulus operator, I'm just going to put it, computes the remainder from integer division. And so what that means is, let's say that we have 13 mod 5. The remainder for this is 3. So if you do 13 mod 5, you're going to get 3. And one thing that I want to point out with this is the modulus operator only works with integers. So the modulus operator computes the remainder from integer division. So if you try and put a floating point number with the modulus operator, you're going to get an error. So if you did, say, 13 mod 5.0, so then you have a floating point number, this is going to result in an error. So this only works if you have integers. And one thing that's kind of nice about the modulus operator, and we're going to see some uses for it a little bit later. A few examples are it can be used to compute random numbers between certain values. Use I want to talk about is we can extract the rightmost digit from numbers. So let's say that we have 123 mod 10, because it's going to pull the remainder. So 10, you can divide 10 into 123 evenly 12 times. So then you're going to get 120, and then you have 123 minus 120 to get the remainder. So 3 is the remainder. Basically, we've extracted this rightmost digit using the modulus operator. What if we had 123 mod 100? Divide 100 into 123 evenly once, and then 123 minus 100 is 23. So we can also, like, let's say we had 1, 2, 3, 4. We can do 1, 2, 3, 4 mod 1,000, and we would get 2, 3, 4. So this is one really useful feature of the modulus operator.